The keynote speakers are confirmed and include Alicia Rainwater, who will present on generational differences in the workplace, bridge generational differences to create a safer workplace. It'll be on day 1. And day 2 will be Dave Caperton, and he'll speak on laugh, to be on the safe side and why the first and best tool for health and safety is mindset. That'll be on day 2. Golf outing is coming up August 3rd. It'll be at Village Green. It'll be a noon shotgun start, and we'll be playing a full 18 holes. As a reminder, this event raises money for each events and the scholarships that we give out as an organization as well. So please, once the presentation is just about over, your phones will probably start buzzing. We'll be sending out a survey for you. Please take the time to fill that survey out. That information that we get from that survey is what we use to bring these types of meetings to you. So we're always looking for fresh ideas for topics, anything that you want an update. That it's been a few years since we've done that topic. So that's the venue where you can let us know as a board what you would like to see, because this is your organization and we need your input in order to make the information valuable to you. So communications, we are on Facebook, LinkedIn, Twitter, and YouTube. Please take the opportunity to like, share, do all of that stuff with your social media accounts with the NRASP account. And we are posting the information monthly, at least 4 times a month on Facebook, LinkedIn, and Twitter. So each of the virtual presentations is also available on our YouTube channel. So if you miss something that you want to go back and see, you can always pull it up on YouTube and review the presentation that way. So, well, as I mentioned, this is our meeting that we do together with ASSP, and we have Kara Felber and Mike Skarsky here, and Kara's going to introduce our speaker today. So I'll turn it over to her. So thank you.
So again, my name is Kara Felber. I am the current past chair of the ASSP Northern Plains section. Standing next to me is Mike Skarsky. He is the new chairperson for the Northern Plains section. And we have partnered with NRASP to bring in a couple of speakers from Mechanics Wear to talk about hand safety. Following this presentation today, CEUs will be offered. We will send out a notification through the Northern Plains section Gmail account. If you are interested in receiving CEUs, please respond to that and let us know, and we'll get that process through MSUM, correct?
Yep, U of M.
U of M. I always get that messed up.
Department of Public Health.
Department of Public Health. Perfect.
And if you have questions about CEUs, feel free to reach out to us via email, our LinkedIn page, or directly to one of the members of the board, and we can get that answered. So hopefully that brings some value to some of the folks in the room.
Okay, so I'm going to introduce 2 of our speakers today. First, we have Michael Pryor. He is the regional sales manager with Mechanics Wear Gloves for the Upper Midwest. He has 22 years of industrial sales, including 3 years with Mechanics Wear, selling and providing hand safety initiatives for the industrial market. Michael provides hand safety assessments for a wide variety of industrial customers. We also have Dan Branson. He has 20 years of experience in the glove and safety industry, specializing in research and development, compliance management, and technical training. He sits on the ISEA, ANSI 105, 107, and Z87.1 standards committees. He chaired the most recent ISEA, ANSI 138 Impact Committee, helping the formation and implementation of the first ever impact standard for gloves in North America. Currently, he is the Director of R&D and Laboratory Services for Mechanics Wear, overseeing their state-of-the-art laboratory located in Goodyear, Arizona. Welcome to Michael and Dan.
Thank you. Get everything set up here for everybody and we'll roll. Hopefully that is working for everybody. Does everybody see it correctly and can hear me? Okay. My name is Michael Pryor. I'm the regional sales manager, as Kara pointed out, for Mechanics Wear. I cover the upper Midwest, based out of the suburbs of Chicago. So I work with a variety of industrial and construction commercial industries to implement hand safety programs. And one presented with the opportunity to bring hand safety to this group, I thought Dan Branson would be the ideal candidate to actually speak towards it, since he's sitting on a number of boards, has written a few standards, and has extensive experience with hand safety. So I'll start with the first slide you have here. And really what it is, it's an explanation of the ANSI standards. The American National Standard for the Performance and Classification of Impact-Resistant Work Gloves is intended to protect working hands in industries where heavy tools, heavy equipment are at work. And ANSI and ISEA really set the standards and kind of govern the standards from that standpoint. We'll start with the impact of gloves, since it's a new standard. CUT's been around for a little while, and we'll touch on that in the second half of our presentation. So the impact standard, in 2015, the labor statistics reported over 143,000 hand injuries in the workplace. Second most in the body part of injuries. So your hands really kind of do a lot of work, and if you injure them, you may be out of work for a period of time, is what it's saying. Nearly 30% of all workplace injuries resulting in days away from work. The National Safety Council averages a cost of $23,000 per work or per injury, including medical and indemnity. 26% of the occupational injuries resulting in days away from work were caused by contact with objects and equipment. So even walking past something, swinging your hands, there's a chance you're going to do some damage to your hand if you're not wearing the appropriate glove, even just walking through a facility. And that includes, struck by, again, that walking pace, crushing, pinching, and vibration. ANSI ISEA 138 2019 addresses a major gap in the performance testing with the 105 glove standard for cut resistance, puncture resistance, abrasion, and chemical protection. It's a lot of information, a lot of statistics, but from here, Dan will be able to kind of fill in some of those gaps for the questions that may arise.
Thanks, Mike. My name's Dan Branson. I run the lab for Mechanics Wear and the technical training aspect of the company. So when there's a desire or need to learn more about a standard, that's kind of what I do. I also manage the global compliance for Mechanics Wear, where we actually manage the standards globally. So we're not just here in the US, we're a global company. So we tend to see much broader wealth of standards in general for gloves. So we're looking at European standards, we're looking at Chinese standards, we're looking at Russian standards, we're looking at every standard we can to try to build better standards here in North America. So there is a standard that actually influenced the ANSI standard, and it was a impact standard in Europe. The issue with that standard was it only rated your knuckle, so it didn't include finger impact protection. So when we took a deep dive at this, we understood there was a big need for it, the 138 standard in general, because glove companies in general, they weren't trying to be misleading by any means, but they would put plastic in a glove and call it impact protective. And what we found was some of that plastic was actually working opposite of its goal. It was actually transmitting the impact even worse into the hand. So we identified that there was a need. That was the first step when we wrote the standard. The second step was, which we'll get into a little bit later, and who does what in terms of ANSI and ISEA, but the second step was to form a committee to write the standard. That was done at the ISEA. And once the committee was formed, then we really got into the details of how the standard was written. It included studies from General Motors when they first came out with electric windows and vehicles. Children were putting their fingers in the windows and breaking their fingers. Included studies of cadaver hands. We worked with the University of Milwaukee, multiple hand surgeons and doctors. We really took a deep dive into, how hands are hurt and affected and related to impact protection. And what we came up with, and we felt like was a very good solution, was ANSI 138 for impact. So the way that this works, the first thing that we did was we looked at a various amount of different test methodology, if you will, like what's the best machine, how do we test it, how do we get the best data without skewing the test methods. And the first thing was we wanted to be fair, so we basically came up with an average conditioning time for the glove before it's tested, because we know that when it comes to plastics and polymers and things of that nature that are typically used in the glove, air, whether it's freezing cold or extremely hot, can affect the performance of the polymer. So we wanted to be on the level playing field, so we established a conditioning time for the gloves prior to being tested. Then we decided to remove the back of the hand. So we cut the glove in half when we test them for impact. The reason why we did that is a lot of gloves on the market already have like foam padding on the palm. We didn't want that padding to give us a false negative when we're impacting the backside of the hand. We wanted a good, accurate reading. So we removed the palm so we knew exactly what force was being transferred through the hand. The third thing we did was establish where should we hit the glove, where are the injuries related. So this was a lot of data gathering as well from recorded injuries of where people were actually hurt. And these were the core spots on the fingers. So every one of those is a strike zone where we hit it with an anvil. Then we looked at knuckles. Knuckles was very difficult because everybody has a different hand, different shape. So what we did to try to address that and get as broad of an audience as we could was we decided that there needed to be 3 assessors when trying on the glove to determine where we strike it. So the first assessor would put his hand in, make a fist with the glove, and he would mark where his knuckles are. So that would be one of those red dots. Then we'd brought in a separate assessor. He would put it in and we'd mark where his knuckles were. Then we brought in a third, and where we struck it is right in the middle. So we took the assessors and said, okay, this is the average spot of where a knuckle is. We're going to hit it right smack dab in the middle. So that's how we defined the knuckle location of where we struck it. This is the actual test method. So it's a twin wire machine. It's weighted. You see an anvil in the center. So it's basically lifted up and it drops down and it hits the glove. There's a sensor measures the peak transmitted force that transfers through the glove. So there's always an amount of energy that's going to make it through the glove, right? So we measure, what we're doing is we're measuring the backside of that force. So in order to do that and to get a good idea of what that material is actually doing, we hit the finger 10 times. So it's basically 1 strike per finger. And then we do the knuckles 8 times. We average it. We average the force between all those strikes. Now this is the performance aspect of it. So once we've once we hit the glove, I'll put it that way. These are the different levels of how we determine whether the material is highly rated or just okay. So these are kilonewtons on the right side. And 1 kilonewton, if it's easier for people to understand, is 224 force pounds. So we are hitting and this is where it becomes really difficult to translate into a job site application. But what we're doing is we're hitting that glove with 5 joules of energy. Then we measure in kilonewtons the force that is coming out the backside of it, okay? So for a level 1 glove, the mean, the average, can exceed 9 kilonewtons. That's what's coming out the backside of the glove. No individual strike out of the 10 that I talked about on the fingers can exceed 11.3 kilonewtons. If it exceeds either one of those numbers, it fails the test and we don't consider it an impact glove. It's just basically decoration at that point. Level 2, same concept, has to be lower than 6.5 and no individual strike can exceed 8.1. A level 3 is under 4 kilonewtons and no individual strike can reach level 5. You can see that level 3 is extremely hard to get to. And we wrote it that way purposely. We wanted to be able to expand into materials that potentially didn't exist today when we wrote the standard. So we did make it more difficult to reach than the others, but it's also highly protective as well, as you can see. In terms of compliance against the standard, we also wrote in a couple things that are important to know. When it comes to ANSI in general, it's really self-regulated. So I can take a glove and I can cut it on my machine in my lab, and I can give you the score and the gram weight, and I can say my glove is an ANSI A4 glove out of my own laboratory. I'm allowed to do that. When we wrote this standard, we wrote it in a way where we wanted to be more fair on a more level playing ground. So we're not allowed to do that with impact standard. With the impact standard, we have to send it to a third-party notified lab. That lab has to be accredited by 17025, which is basically just ensuring that a third party comes and inspects your machinery and ensures that it's calibrated correctly to make it more level across the playing field. And then we have to provide documentation. Here's the documentation that it was done in a third-party lab. So we don't have to do that on any other ANSI standard for gloves. This is the only one that we've written in that manner. So what you're getting is true testing from a third party, or it should be. If you've got a self-assessed impact, let's say flyer from another company, then they're not following the standard correctly. They should have tested it independently. So this is about labeling and marking. So understanding the standard, understanding if gloves have been tested for impact. So you'll notice on the bottom, it's ISEA ANSI 138 level 2. So that's where mechanics chooses to mark that glove in terms of compliance. And it's always stitched inside a cuff label. So if you ever see that icon with a number next to it, that's level of protection for that glove. Some people will put it on the outside of the glove. I think we have a couple gloves where we put it on the outside as well. But that's the symbol that you want to look for to see if your glove has been tested and protected. This continues on in labeling and marking. Because the standard is new, it is a fairly new standard. And it takes years sometimes to train the industry all the way down to the end user level of what is appropriate and what is not. When it comes to markings, you want to pay attention to the standard itself. So the standard says that if my knuckle was rated a level 2 and my finger was rated a level 1, I have to claim the lowest performance score across the entire glove. So if it's a level 1, if that was the best score I got, then it's all level 1. So in order for me to claim a level 2 glove, my finger and my knuckle both have to test to that level 2. So what we see here is an example of not following the standard correctly. So on the bottom of the page, you'll see that they're claiming that the impact on the fingers is 1 and the impact on the knuckle is 2. So it's not fair to do that for a lot of different reasons. Okay, I can adjust the thickness of my polymer at different levels. I can cheat the test in essence. I know where the strikes are going to be. I can then design TPR to reflect the scores that I want, protecting you correctly. So that's why that's not allowed. So you want to look for that. If you see 2 scores, you know it's not compliant. There's only 1 score, and it's a mean between both the finger and the knuckle. So that's something you want to pay attention to when you're looking at your gloves too. So what was the issue? We kind of touched base on this earlier, but you'll see, a lot of different brand names out there for impact protective materials, and a lot of it will range from your foams like your EVAs into thermal plastic rubbers or silicones. It can really range across a lot of different materials. This is just kind of talking about how the mechanics ware was able to, and you can't really see it very well, and I apologize, it's cut off on the screen, but there's a logo on the top that says D3O. And so D3O is the evolution of impact materials within our industry, to be honest. If you look at this glove, this is just a standard TPR, standard EVA. So what we've done is we've basically gone from this material into this material. And what D3O is, this is how mechanics ware is able to achieve a level 3. So first I want to say achieving a level 3 impact glove is rare. You can Google it. There's probably 3 or 4 gloves on the market that actually can achieve it today. Most gloves that do achieve it, the back of hand material is probably 10 millimeters thick. It's extremely thick and cumbersome to work in to reach a level 3, or you're using a smart material. That's what we call D3O. That's how we classify it. We classify it as a smart material. What it does, and this is going to show my age a little bit, but if you were young as a kid and you ever played with cornstarch and water, if you put a bunch of cornstarch in water and you just put your finger in it, it gets wet. If you hit it hard, your hand stays dry, right? So that what that is a non-Newtonian fluid, okay? We took that technology, that concept, if you will, and we put it inside a polymer. So on the back of our glove, when it says D3O material, how it works is in its free state, you can't even hardly feel it. So when you're moving the glove, you wouldn't even know impact protection is there. The minute that glove is hit with an amount of force or energy, those molecules seize up and dissipate that shock before it goes through your hand. So I'll give you a quick example of that and how it works. And I hope everybody can see it. And Mike, maybe you can help because I'm holding the mic. Try to do it. Yeah, maybe on that table in the front. He's going to show you D3O versus EVA foam.
We apologize for the people at home.
Yeah, I apologize for you guys on screen, but we do have a video of this that we can share later. So first I'm going to show that the EVA foam is 5 millimeters thick. It's fairly thick for a glove. We want to try to keep things as thin as possible. This is our 2 millimeter thick D3O foam, right? So it's quite thin. It's very flexible. It's very soft. So when you take the striker and you drop it on EVA foam, you're going to see it rebound, okay? See how it bounces. If I could hit it in the center, it would be better, but so you see how it'll bounce off the material. And what that means, all that energy is going through this EVA foam, hitting your hand and rebounding back through your hand, okay? So that's EVA. Here's D3O. You see that the rebound is very minimal. It's absorbing that energy and spreading it. Now, if I had 5 millimeters of D3O next to 5, it wouldn't bounce at all. But I'm trying to compare 2 millimeters versus 5. You can see the significant difference in the rebound, right? So that's what that is. So we've taken this material and TPR to reach a level 3. So pay attention to when you're picking your impact gloves. What is it? What's in there? What makes it impact protective? Because sometimes the impact protection can work against you. Like I said, if it's EVA, that's actually going through your hand and rebounding back up. So right now we've launched IP technology with D3O, which is just what I talked about. We basically took the foam and we turned it into a polymer. And what that's doing right now is you get this, not only do you get the best protection, but you get breathability, you get flexibility. It's super lightweight. It's tested to the highest standards. It's also Okio-Tex. So it's just basically ensuring, what that means is basically there's nothing in, you could eat that and it wouldn't hurt you. There's nothing harmful for humans within that polymer. And it's level 3. So again, you can see the impact, how thick it is, which is very minimal versus a 10 millimeters of EVA to achieve the same thing. So let's talk about how we formed it real quick. ANSI or ISEA, what's the difference? So a lot of people don't know this, but ANSI is not a government controlled agency, nor do they actually develop standards. They govern them. So other people write the standards that they implement. that they choose to implement. They do control that aspect of it, but they actually don't write it. Their job is basically to coordinate those efforts between the organizations that do develop standards. So they say, hey, these are the rules that you have to follow when you're going to develop a standard. So it's fair across all platforms. They establish committees to review those standards that are submitted to them. So anything that's written, they look at and approve prior to putting it out in the public. They outline the rules, the methods, and basically they are the final authority in implementing a standard. The ISEA is one association that actually writes standards. That's the association that Mechanics Wear is within. We sit on multiple committees there, and when needed, we chair those committees and potential boards as we work through, I guess, problems. These committees consist of our own competitors, so we're not going in there and just writing standards for Mechanics Wear. We go in as a group, unbiased, with the only thing in mind of protecting the end user. So we work side by side with MCR and PIP and ANSI and whoever's on the committee to write these things to better protect the entire industry. Once we've written them, then we submit them to ANSI. And that's why you'll see in the standards themselves, if you ever read them, it's the ANSI/ISEA impact standard, because it was developed by ISEA, it was implemented by ANSI. So now we're going to transfer over into CUT, and we will take questions at the end. If you guys have questions about impact, we can go back, but we're going to transfer over into the CUT standard now. So the CUT standard is fairly new. I mean, again, it takes years and years and years to train all the way down to an end user level when something new is introduced. But in a nutshell, CUT standard there used to be and there still is, but it was a rotary blade. It's basically circular. And we would take a glove and we'd take that blade and we'd run it back and forth across the glove until we put a cut into it, right? And that was the standard in a nutshell. And that blade was weighted, of course, and the more weight, so on, so forth and so on. But what we decided was, when you take something that's extremely sharp and you put it on something that's made to resist it, it dulls the blade. So eventually we realized, and after a few years of experiencing this issue, we realized that that wasn't the best method. We needed a new blade for every cut. So we wrote the new standard. And when we did that, there were a few other things that we changed, but this is the basic concept of the cut standard. So it's a TDM machine. That's the machine that actually performs the test. And you'll see, if you look right in the middle where that guy's fingers are, it's a razor blade. It really is a razor blade. So and what we do is we weigh that razor blade down on top of the glove and we run it across the top of the glove. There's a test specimen before that. It's cotton canvas. That gives us a baseline. And then there's just basically a mathematical formula that transfers that difference into a cut performance score. So every time we run that blade across that material, we change that blade out and we put a new blade on and we do it again. That way we're not dulling that blade down, and we're getting true measurements off of it. These are the cut levels. These are the existing cut levels. And I transferred those the best I could into pounds. I kind of averaged a little bit. But yeah, a level 1 is roughly 1 pound of force. So it's a 1 pound of force, which causes the cut. And then it just goes up from there, 500 to 2 pounds, 3 pounds, 4 pounds, all the way up to over 13 pounds. The old standard ended at 5, but we did adjust the gram weight within those two to give us a better scope or a better range. So this was the old, and you'll see that the old one did go up to level 5, but a level 5 ranged between 3,500 grams and 6,500. And we just felt like that was just a huge spread. So we just broke it out more. And that's really one of the biggest significant changes to the standard, is we went from a level 1 through 5 to level 1 through 9. And again, when we wrote this, level 9 was really hard to achieve. It took 3 or 4 years for us to get up to a level 9. It was difficult. But once the I guess the technology caught up to the standard. Now you see level 9 every day, and actually you see it in some pretty cool technologies too. So it was almost a way of challenging the industry of doing better as well, which was fantastic because now people are better protected. So Mike's going to talk about best practices within your organization for hand assessment.
Should be relatively simple, I would say, as far as best practices. I'm sure most of you guys have already implemented a lot of these practices as far as creating hand safety, but a good review is, assessing your application, understanding what's causing, the lacerations or the punctures or even the pinches, breaks, and then figuring out what the hazard actually is, and then integrating and engineering as many of those process or controls into the situation to reduce that hazard, right? And then reassessing the hazard. And it's kind of a cyclical process to go through when you finally figure out that, okay, you've reached the right PPE levels. Now you can control it with gloves, sleeves, hats, eyewear, etc. But PPE at the end of the day shouldn't be your first defense to prevent cut hazards. That is our presentation. So if you guys have questions, Dan and I can answer those. Go ahead.
The impact standard probably doesn't really reflect crushing injuries of the hand. Would those materials you have help in a crushing situation?
They do. Yeah, they do. And again, it depends on the material that you're looking at. So, D3O is very rate sensitive. So it will perform better with high impacts versus slow crushing injuries or slow impacts, if you will, or crushing. But it does still protect. There is still a level of protection. We definitely intended to expand this this standard. This was kind of phase 1. It was a big deal to implement a standard, number 1. It usually takes 5 years to implement one of these things. I think we did it in 2. But the idea was, we need to get something out there rapidly and quickly. So that's what we did. We're going to start here, and then we're going to expand it into other potential hazards that need to be addressed as well. So I think where you'll see the evolution of 138 will be to address more than just back of hand, where you'll see crush and other injuries related to impact dangers as well. You may even see it expand into anti-vibration. That could be a completely different standard, but you'll start seeing an expansion for sure. So it was really just intended. There was a huge hole. People were getting hurt. We're like, we have to fix it. We have to do it fast. This is round 1. And we all knew there would be a round 2, round 3 to expand it even further. But it's a good question. It doesn't currently necessarily address it in the standard right now, but impact materials should protect to a certain level for crushing injuries, for sure.
The cut standards, the metrics you had as far as pounds that would protect pound of force with a 1.1, all the way up to 6 or whatever it was. How do you determine? Is there an estimate of how many pounds you generate in a box cutter or something like that?
Right.
I mean, obviously more than on dexterity, probably the lowest.
Yeah. Man, wouldn't it be great if the standards could address every application, right? But there's so many applications. Yeah. So it's rough. What I would suggest is this. I would suggest that you call somebody like Mike, who can come to a job site, with that experience and assess the application. That's also great with OSHA. You can be like, hey, we had a professional glove person come in and assess the applications and assigned a level to it for us, which is going to be helpful if somebody does get hurt. But it's very difficult for me to say, a hammer is going to protect this person against this amount of force. And the reason for that is like, if we're looking at the impact standard as an example, and you said, well, what do I need to ensure my guy's hands don't break any bones, right? Well, there's too many factors involved there. Age, number one, is a factor within your field. Hydration is a really good factor, actually. Male versus female is a factor. So, it's very difficult to say, you need a level 1, and here's why. I think the best way to assign a level on a job site is to simply understand who's getting hurt and why, which just involves a glove audit. You just have to go out and audit the plant and say, okay, clearly these people get cut more than these people. This is the level of protection they've been in currently. We need to build it up to this level and assess it again. Yeah, that's the best practice that I could offer. I'm a standards guy. I'm a compliance guy. Honestly, I want to try to, eliminate it to 0. So I overcompensate. I'm always like, why don't you just start at level 9, and work your way down. If you don't have any injuries at 9, great. Go to 8. If you have an injury, go back to 9. And try to play in that realm. But I tend to overcompensate. I want to be over compliant. Our goal as a company, Mechanics Wear, I can tell you, is never to be just in line with a standard. We want to be above it. We want to be ahead of it. We're always thinking, okay, now that we're at 9, how do we get to 15? Right? That's the race.
How is the workability with the glove now in the past? Some of the choices that we've made, the glove is just so stiff to get to a level 4 or 5 in the old system. How is the new,
From a cut standard
well,
or just
more of the
impact?
the impact side?
Sure.
I'll give you a couple. You can tell me what you think. So this is a level 1. So you think that this would be less flexible on that. This is your level 1.
Yeah, for both cut.
There's a flexibility rate the same.
Figures are tighter. Let's not go there.
Are they both XL?
They're a little bit tighter. This is the large.
Okay, so that you had an XL and large. I gotcha. So you
I
need
can
an
feel
XL.
it. Yeah, I feel it being tighter across the top.
Sure.
But yeah, it's
It's not the stiffness. It's not the card, right? It's not restrictive is the point. Yeah. If those were both XLs, you'd have a very similar fit and feel. But you can see the difference in height. That's really the difference. Most people, once you pass on level 3, this is going to be out to here. And then it's really stiff.
okay. I don't know if you can repeat some of that into the mic. I don't know if you've got
Yeah, basically it's the thickness of the material going into the gloves. From a 1 to a, you've got basically double the thickness to get to a 3 with using the TPR as it stands, right? D3O allows for thinner material to allow for better impact protection. And that's kind of the process behind it. Plus then you look at the honeycomb shape of and it's printed on the gloves versus sonic welded for TPR. So the hexagonal shape actually does play a purpose other than looking pretty cool. It allows for that flexibility in the hand, right? And then, you take a look at the individual operators as they're working, that low profile, the back of hand protection helps them work into tighter, smaller areas. Plus you got good dexterity, nimble fingers, a lot of little features that you don't really think about when building a glove that goes into the technology behind it.
Do you have other technology and forward to improve correction technology to help with them on a course that people have to sustain while holding them out?
So that's the second question we've had regarding gription technology today. What kind of application is it? Is it an oil, metal working application?
It
Is
could
it?
be anywhere and everywhere. Sometimes there's oil involved.
Okay.
Sometimes there's not. But what I see with musculoskeletal disorders is the amount of force that people
Yeah, the ergonomics behind being able to grab something. So I'm going to give this to Dan because he did a great job of explaining it this morning.
Okay, so when it comes to grip, obviously the application makes a big difference, right? What are you working with? How long are you working with it? You know, are you swinging a hammer all day long doing the same thing? Are you doing multiple things? There is actually some test methods that we do put our gloves through to give you an idea of that. I can't remember the exact protocol, but it's basically we put a glove on we actually take a test subject and they perform the test without a glove. Then we put a glove on it and they perform the test again. And it's basically you grip a cylinder and you twist it back and forth for an extended period of time. And it gives us an idea of what the effect is on a grip, on gripping onto an object. It's part of a dexterity test. So then we take that same test subject and they have to move 25 pegs off a table without a glove into a pegboard, kind of like that thing at Cracker Barrel. And then we put a glove on and we do it again. We can do it in different temperature ranges. So that also affects grip. How cold is it? How hot is it? You know, those types of things. And that goes all the way down to like the test subject has to have 20/20 vision, and there's a lot of protocols behind it. So we try to get the best data we can, but ultimately grip and let's say, I think really the end result of why people ask that question is hand fatigue. How do we reduce hand fatigue, which could affect dropped objects and a whole bunch of other standards that you guys have to worry about. And it really just goes back to the hand assessment. You know, in order for us to really give you good data, we need to understand the application. Because if you're working, let's say, in oil versus salt water, that's just one example, we're going to change the polymer of the glove between those two applications, because we know that, let's say, PU will break down rapidly in warm salt water versus nitrile won't. So we would want to look at that. And let's throw this out there. PU is the #1 selling polymer in the market right now because it's cheap. So we got to start changing the mindset of don't buy the cheapest glove, buy the glove that's right for the application, because that's really truly going to affect the outcome of the performance of your employees. So really, I would just go back to have a glove guy come out and do an audit, have him look at it, and then he's going to be, hey, that's the wrong polymer, switch it to this, you're good to go. That's going to reduce hand fatigue, it's going to increase grip, it's going to solve all your problems. But there's so many different polymers that it really does take kind of a level of understanding, you know, how those polymers interact with different things. Give you an example of that, nitrile would be the second best selling polymer on the market. Depending on the nitrile that you use, if you use a flat nitrile, there's high levels of surfactant, soap in that glove. So the minute it gets wet, the soap starts coming to the surface, and it does really affect your grip. If you're using a foam-based nitrile, there's less soap in it. So it's all, and again, depending on, like, let's say if you're working with sheet metal, flat nitrile is great. It grips through the oil. It's perfect. It's wonderful. It's not getting wet. If you switched that same application to an oily situation where it's like mud, like where you're in oil and gas, it's horrible. It works against it because there's too much water in it. So a lot of different polymers. From a mechanics wear standpoint, we are cutting edge in water-based polymers. So we'll be honest, everybody knows us for our cut and sew product. Nobody really knows us for our coated products, which we just launched, I think, last year. When we launched that, we didn't want to be a Me Too company. So we researched a lot of different polymers and what those polymers did and how they interacted with different things. And one of the things that is coming in the future is you're gonna hear a lot more about DMF. DMF is in a lot of solvent-based polymers that are on gloves. DMF can be absorbed through your skin. So the minute you put it on your hand, it can be absorbed. It's being referenced by a lot of government agencies as kind of the next asbestos. So what we did is we took a solvent-based polymer traditionally, and we made it water-based. So we removed all the dangerous chemicals out of it. So our gloves are safer, they're non-toxic, but they do react differently in different environments. We still have to carry some nitriles and some traditional solvent-based polymers based on the applications that are out there. That's a really long-winded answer. I apologize.
So going forward, one of the things that we find a challenge with in healthcare are they looking at anything that are cut resistant for sterile environments? We run into a lot of.
There, I don't have that solution, but there are solutions out there. There are cut level. I believe we have a cut level 3 disposable nitrile. Is it abrasion? Abrasion. They do exist.
Okay, so where we're running into issue with people doing work in sterile and both unquote clean areas.
Yeah.
And yeah, that's what I was gonna say, that
Having clean area pretty much accepts like 80% of the market.
Right.
And so from that standpoint, we haven't found anything, at least I haven't come across anything that makes sense for the sterile environment or clean work environments in any of our gloves at this point.
because they still have to work in these areas, there's,
Yeah.
stuff remodeling that goes on in these areas. That's
Sure.
still,
Yeah, and I imagine eventually we'll get down that path. We're always looking for the next,
there you go.
big win or big opportunity to find, right? So the one thing I would touch on with Dan saying that, have a glove assessment, I will qualify that and say, have a good qualified glove assessment come in and do it, because the way I go about it is if I don't have the solution for you, I'm not going to tell you I've got the solution for you. I will tell you that there's another company out there that you need to search out for. And that's what you want. You want somebody that's going to come in and be honest with you and tell you, hey, I've got the right solution or I don't. Okay. Any other questions? Yeah.
The fire resistance on these gloves.
So we do offer some flame resistant gloves. So depending on, again, as far as fire department applications, or if you're working in foundries or welding and stuff, we do have an assortment of gloves that match that. There are standards. I don't know if you want to touch on some of the FR standards a little bit.
There's a bunch of FR standards. So there's the first thing that I would look from a glove aspect is it treated or is it inherent, right? So if it's treated, it's going to eventually wear out, or if they wash it, it becomes less protective. The protection value drops. So it's really, again, it's important to what is the application, because in some cases treated materials are fine. In some cases you want an inherent material. So look at the application, and based on that, there's different standards for gloves. But if you're looking at like a foundry application, a lot of those guys actually write their own protocols based on heat that's being put off the equipment. I mean, you can get all the way up to, I don't know, I've seen stuff in the 3,000-4,000 degree range of protection, depending on kind of what it is. But keep in mind that most FR standards are written, which is almost backwards, but they do need to be rewritten. They're kind of old, but most of these standards are written based on time to injury. So it's not really, here's a protection value. It is, but it's a protection value based on time to injury. So what that means is they're going to say, oh, this glove is rated 2,000 degrees. Well, it's rated to 2,000 degrees for 15 seconds until you get a second degree burn. Does that make sense? So it's based around the exposure time. So we get a lot of that in our customer service department, a ton. How can I work? How long can I work in this temperature? We can't answer that question because we don't know the circumstances. It's like saying you could, this glove is rated to 30 degrees. Well, if you're in 30 degree weather for 14 hours, you're going to be hurting regardless of what I put on your hand. So, you got to look at exposure time. You got to look at, what it is, because you could be, especially when you're talking FR, you could be talking about molten metal standards as well. Most of those are European or ISO, which is International Standards Organization, and they'll literally melt metal and dump it on the glove, and it'll either bead up and fall off, or it'll light the glove on fire. So there are standards. That standard is EN 407. That was just rewritten last year. It's EN 407 2020, and that will give you that gives you, excuse me, I'm trying to remember if it's limited flame spread. So they put it underneath a burner and they burn it. It'll give you a contact heat rating. It'll give you a convective heat rating. It will give you small molten and large molten metal ratings. I think there might be one more that I'm missing, but it'll go through a bunch of tests, and there are levels associated with each one of those. Personally, I think that's the best one on the market for our use. It's actually in a European standard, so that would be the one that I'd push you towards is the 407. If you're the only thing that I need to caution you with is there is a standard specific to firefighters and wildland fires. That's completely different. It's governed by the NFPA. Yeah.
Any other questions?
Perfect. Got it. Okay. Got it.
Well, we appreciate you guys' time today and the opportunity to share some knowledge with you guys. If there are any other questions that you think of or applications that come up, you can reach out to Dan and myself. We're typically up in this area. Well, I'm up in this area at least 3 times a year. I've got Tony Frederick, who is with BSA. He's our rep group for the area, and he's based out of Minneapolis, and he's in this market monthly. So communicate with any of us if you have any questions or any needs for hand safety assessments or just want samples.
Well, thank you. We really appreciate this information. For the group, they've got some samples up here and some literature. If you have questions, take some time to come up and visit with them. The survey did go out. I received it on my phone. So please take the time, go through, answer those questions, and give us some suggestions for upcoming events. So with that, thank you. If you ever have questions, you can reach out to the NRASP website and reach any of us board members through that, or you can reach us in person if you'd like as well. So thanks again. Be safe and have a good day.
Thank you.